Traveling at 4 times the speed of sound, the Starstreak missile is the fastest short-range surface-to-air missile in existence. With as much lethality as speed, it is capable of destroying targets from over 4 miles away, be it a drone, helicopter, fighter jet, or UFO. This weapon is enough to turn the tides of any war in favor of its operator, which is why the UK is packing Ukraine full of it to aid in their resistance to the Russian invasion. But with the US already packing Ukraine full of Stinger missiles for the same purpose, there is an inevitable head-to-head brewing between the two missiles, which we'll discuss in this video as we break down how each weapon equips soldiers with firepower meant for tanks. The Starstreak dates as far back as the early 1980s, when an evaluation of missile and gun options to increase air defense capabilities showed that a high-velocity missile system was the route to go. Subsequently, a general staff requirement was drawn up with the requirements of the system, specifying the requirements of 3 launch platforms for the missile, a self-propelled launcher to be mounted on vehicles, a 3-round lightweight standalone launcher, and a man-portable launcher, all combining to make the Starstreak as flexible and adaptable to whatever battlefield situation, which it truly is, as can be seen in Ukraine. So far, the Ukrainian forces have operated in its man-portable and standalone launcher modes, where the missile is transported in a sealed launch tube. This tube is then attached to an aiming unit for firing, where the aiming unit's optically stabilized sight is used by the operator to track the target. This initial tracking enables the aiming unit to compute the right trajectory that would see the missile and target married in an explosive union, literally. And thanks to the supersonic speed of the missile, even fighter jets would have an impossible and insufficient time trying to outmaneuver certain destruction. This means that any target within the missile's 4.3-mile combat range and below its 16,000 feet operational ceiling is likely to crash in a cloud of its own smoke, as the missile has a triple impact system to make sure of that, which we'll get to in a second. After tracking the target, factoring the wind direction to the aiming unit, and providing super elevation, which is simply an additional angle of elevation above the angle sighted on that corrects for the effect of gravity of the missile, the operator pushes the fire button, releasing a 30-pound, 1.4-meter-long beast of a missile, with 3 explosive dart submunitions as its warhead in the first stage of a 2-stage flight. The first stage sees the missile launched from the tube by a Royal Ordnance Brambling cast double-based propellant blip rocket motor that burns out before leaving the tube to protect the operator from the backblast. 4 meters away from the launch tube, when the missile is at a safe distance from the operator, the second engine, a Royal Ordnance Titus cast double-based propellant, is activated, rapidly propelling the missile to Mach 4 speeds, twice faster than any fighter jet in operation today. After the second stage burns out comes the really revolutionary bit of the Starstreak missile. The 3 dart submunitions are released, each with a length of 15.6 inches, 0.87 inches in diameter, and with a mass of 32 ounces. About half the weight of each dart is an explosive charge, detonated by a delayed action impact-activated fuse. This detonation method means each dart first pierces through the target, dealing initial damage. On this impact, the dart's tungsten alloy housings fragments inside the target for increased lethality, dealing a second damage, while the fuses of each dart's explosives are activated and immediately after, boom, which is the third and final damage, tripling the Starstreak as a bullet, a fragmentation bomb, and a missile. This is the triple impact system we mentioned earlier, and as you can guess, it's mighty effective. But rewinding a few seconds back before impact on how the darts stay on course to the target, they are simply guided by laser beams. To fly according to this guidance, each dart consists of a rotating forebody with 2 canard fins attached to a non-rotating rear assembly with 4 fins. This rear assembly houses the guidance electronics of the dart, including rearwards facing sensors that senses the 2 projected laser beams from the aiming unit down below. This is why the Starstreak is said to have a semi-automatic command line of sight guidance system, as the operator is required to continually point at the target even after firing. However, this guidance system comes with pinpoint accuracy, as the laser beams from the aiming unit that guide it are modulated in a two-dimensional matrix and painted upon the target for easy tracking. By examining these modulations, the dart's sensors can determine the dart's location within the matrix and then ensure that the 3 darts are steered in a way that keeps them in the center of the matrix while flying in a formation of a 1.5 meter radius and with enough kinetic energy to maneuver at up to 9 G-forces, which is more than enough G-forces to make a full-grown human black out, by the way, and comparable kinetic energy to a shell from a Bofors 40mm cannon. Yes, a cannon. The Starstreak entered service in 1997, and so far, 7,000 units have been produced by Thales Air Defence, a defence contractor based in Belfast, Northern Ireland, that had to defeat the British Aerospace Corporation in a head-to-head competition to win the contract from the British Ministry of Defence to develop the Starstreak. The Starstreak is, however, involved in a competition once again, but this time to prove its lethality and dominance in the manpad space against a famous American challenger known as the Stinger. Produced on 3 continents and operated by 30 militaries around the world, the Stinger is a celebrity man-portable weapon to say the least, a status that could only be achieved by sheer competence and effectiveness. The Stinger operates as an infrared homing surface-to-air missile, which can be adapted to fire from a wide variety of ground vehicles, such as the M1097 Avenger, M6 Linebacker, and Humvees. A helicopter-launched version also exists, known as the air-to-air Stinger. While the Stinger's platform versatility has been far better explored than the Brits have done with the Starstreak, the Starstreak's guidance system has an advantage over that of the Stingers, as the Starstreak cannot be jammed by infrared, radio, or radar countermeasures, nor can it be suppressed with anti-radar missiles, which is more than can be said about the Stinger. However, the Stinger does boast some impressive stealth features of its own. Being a passive seeker, it doesn't emit radio waves to locate targets and so has leverage over radio-based countermeasures. The Stinger missile is 60 inches long, 2.8 inches in diameter, and weighs 22 pounds. But packed with the necessary components of a launch tube and integral sight, fitted with a gripstock and identification friend or foe (IFF) antenna, the Stinger clocks in at approximately 34 pounds. In terms of operation, the Stinger has an operating range of 2.36 miles, which is 45% less than the 4.35-mile range of the Starstreak. Before going at a target though, it must launch first, which it does in a soft launch setup similar to that of Starstreak, where it is launched by a small ejection motor to push it a safe distance from the operator first, before launching a Stage 2 solid fuel sustainer. It's either this or having manpads operators resigning on the first day of work. The Stage 2 launch accelerates the missile to a max supersonic speed of Mach 2.54, which, although impressive and faster than many fighter jets in operation today, is still more than 35% slower than the Starstreak missile with its Mach 4 entry. At this point, it's quite clear that the Starstreak came to this knife fight with a bullet, fragmentation bomb, and missile, quite literally. But to be fair to the Stinger, it was designed in 1967, 13 years earlier than the Starstreak was, and so the Starstreak by default had the edge of a decade of advancements in technology, which has come to play here and in its favor. The US Army recognizes the almost obsolete status of the Stinger and have already requested, in April of 2022, for information on a replacement manpads that would build on the Stinger and support many of the Stinger's hardware, because the Stinger, contrary to what the numbers may show, is a lethal weapon in the battlefield, which is why it is still being manufactured by Raytheon Missile Systems in North America, produced under license by Airbus Defence in Europe's Germany, and by Roketsan in Asia's Turkey, with 70,000 missiles produced so far, which is about 1,000% more than the number of Starstreak missiles produced. But with time, that gap is only naturally expected to close, as the Starstreak is a weapon that no military operating it would want out of stock, especially with Britain, as said earlier in this video, shipping tons of them to Ukraine, as Ukraine just can't have enough of it. This is clearly seen in a video showing the Starstreak splitting a helicopter in half, which shouldn't be much of a surprise as tungsten, upon which the Dart submunitions are based, has the highest tensile strength of any element on Earth. But scientists believe that outside of Earth is an element with an even higher tensile strength, an element that can only be discovered if you subscribe to this channel and give this video a like. And that'll be all for now. Thanks for watching!